Hello dear programmers, how are you doing today? A very warm welcome to the channel, and topic of this video is Introduction to Pandas series. So what is Pandas? Pandas is an open source BSD licensed library which provides high performance, easy to use data structure for data analysis in Python programming language. The data structures are of two types, they are DataFrame and Series, and of course, as the title says, in this particular notebook we will be looking into Pandas series. However, I will highly recommend you to go ahead and look into my tutorial on Pandas data frame before continuing on this particular video. It will help you to understand Pandas series in a better way. So let's start with what is a Pandas series. So technically we can say that Pandas series is a one-dimensional labeled array capable of holding any data type. So in layman terms, a Pandas series is nothing but a column of an Excel sheet. As you know that the Pandas data frame is nothing but an Excel sheet in a layman terms. Similarly, a series is nothing but a single column in this particular data frame. Okay, so in this particular picture, name, age and designation each representing a single series. So that is what series is all about. Why we need series? Because Pandas data frame contain lots of data, and if you want to work on a specific set of data, series is extremely useful. Now one thing to note over here is that Pandas series is independent and not related to data frame. It's true that most of the time we work on Pandas series and data frame together, but series is independent and can have its own existence without the existence of data frame. Okay, now how to use Pandas series? Let's use some logistic. I am importing pandas as pd and numpy as np. Now how to create a Pandas series? There are two ways to creating a Pandas series. I can call a series function of pandas and pass a Python list, or I can pass a NumPy array. Now there is one limitation with series which is not available with Python lists, is that it has to be homogeneous, and that's where NumPy arrays fits in beautifully, because NumPy arrays are homogeneous arrays. So let me just go ahead and execute this code, and you can see that series list will look like this and series NumPy will look like this. Okay, I have created a series with 1, 2, 3, 4, 5, 6, and I have created a series with NumPy array with 10, 20, 30, 40, 50 and 60. Now you can see that similar to the way it was happening in case of Pandas data frame, a row index number is automatically added over here in both the cases. Of course, there are various reasons of not to like this particular row index, so we can provide our own row index numbers. Incidentally, we can provide a NumPy array also as part of row index number. So in this particular case, I know there are 6 elements. I am calling a NumPy arrange function which takes 0 to 12 in a sequence of 2. So if I go ahead and use this, you can see that the row index numbers are 0, 2, 4, 6, 8 and 10. This is inclusive, exclusive, including this and excluding this. Not only this, it's possible to provide index as in here. As you can see that A, B, C, D, E, F are row index number over here. Since row index are just NumPy arrays, we can just use them separately and do some operations as we do in different NumPy arrays. Just now we talked about getting a Pandas series from NumPy array or from a Python list. Now let's talk about how we will create the Pandas series using Python dictionary. So as we have seen in my earlier videos that using Python dictionaries, it's very easy to create a Pandas data frame, because dictionaries keys maps easily to the column header and values to the values. So it's kind of very nice mapping between Python dictionaries and Pandas data frame. But what if I try to create a series out of a Python dictionary? So here is how it will happen. I am creating a simple dictionary and I am creating a series out of that dictionary. Look at this. The keys become the row index value and value becomes the value of that particular row index. So this is the difference between creating a data frame from a dictionary and creating a series from a dictionary. When we created a data frame from the dictionary, the keys become the column header and value becomes the value of that particular column. But in case of series, the keys become the row index number. Now you will be asking a question, what if I pass a list as a value? So we can see that it changes nothing. The list becomes the value of that particular row index number. Now, as I have explained earlier, most of the time we will end up using both data frame and series, especially to work on some of the specific data frame columns. So let's see how we can extract a series from a data frame and how we can work on that. So let's go back and create a data frame which we have created in my earlier video. So I have a data frame which looks like this. There are 3 columns: age, designation and name, and there are 5 records. Okay, so you know that I can just get the column by calling the data frame dot column. This is the way I get the name, this is the way I get the age, and this is the way I get the designation. So when I am calling a column name and getting a column from a data frame, we are getting nothing but a series. It is true for all kinds of syntax. So if I am using a different dictionary syntax as a df name, this also gives me a series. Nothing changes. These are the two ways of accessing a column in a data frame. This effectively means that I can actually get the series out of the columns, and if I just print the series, it will print like this. Okay, now I got the series from individual data frame. Now using this way we can get the series if we know the name of the columns. What if we don't know the name of the columns? No problem, we can just iterate through individual columns in a data frame and just get each and every column independently as a series. So here is a code which does the same thing. I iterate through columns and append the series in a list. So this is how my series looks like now. Okay, here I don't know the name of the column, but still I managed to get all the series. Okay, till now we have seen creation of a series from a data frame. It's also possible to create a data frame from a series. So a pandas data frame is nothing but a combination of series. It can be a single series or multiple series. So let's go ahead and see how we can create a data frame from a combination of series. For example, I have two series right now, series name and series age. Now let me see how this series name and series age looks like. This is how these two items looks like. Now let me create a data frame from series. I am creating a data frame from the series and passing name and age, and let's see how it looks like. Here is how the output looks like. You will be surprised to see that, but it's true that if we combine the series to create a data frame, the row index becomes the column and column becomes the row index numbers. It's very similar to creating the transpose of your matrix or transpose of your existing data frame. Now, you have to note one very special thing, that this is not applicable if we don't pass the array syntax. So in this particular case, the column name as well as row index values are preserved over here. Unfortunately, we cannot pass more than one parameters. If you want to create a data frame out of multiple series, you need to pass multiple series using array notation. So this will happen. And even in case of single series, if we pass the data frame using this array notation, things changes where row index becomes the column name and column becomes the row index number. Okay, this is something where many people get confused. Just try it again and again and get comfortable with this particular thing, because you can get a series out of a data frame, but when you combine those series to get back the data frame, you are not getting the same kind of table, you are getting a kind of transpose thing. Similar behavior happens when we create a data frame out of dictionary. Let me go ahead and see what our tdict looks like, and if I pass the tdict with the list parameter, this is how it looks like. You can see that when I pass the tdict inside an array notation, I can also create a data frame by passing multiple dictionaries like this, and this is how it will look like. This is very similar to how I get a data frame from multiple dictionary. Series can also be generated out of a scalar value, so that's not a limitation. You can provide single value also in a series. Now just like pandas data frames, series are having many helper functions which is very useful in analyzing the data. For example, let's take the mean of the age. You can get 30. Let's take the size of a particular series, which means number of elements. You can get 5. Let's get the unique elements out of a particular series. You can get these unique elements from designation, and you can get back the array of a particular series by calling toList. Okay. Now, once we have series which contain multiple items, which will be the case most of the time, series Just like other data structures in Python are also iterable, and we can iterate through this with a very simple for loop. Okay, and we can also iterate through row index number by using the keys function, and here we will get the row index number of that particular series. So that's all about basic usage of Pandas series. I hope I was able to explain things in a simplest possible way. If you have any queries, questions and concerns, please write in the comment section. I'll get back to you. Once again, thanks a lot guys. Thanks for watching. Please do not forget to like, share and subscribe. Thank you. Thanks a lot.